This video is for lesson 212 homework. All right, number 1, what is the name of a numerical value that assesses the strength of the linear relationship between two quantitative variables in a set of bivariate data? Yuck, right? This is the correlation coefficient. And this is that little half page that I gave you Friday. Okay? Who's got my book? I got it. I got my book.
Is that a correlation?
Correlation, C-O-R-R. Here's it. Here's it written big. All right, correlation coefficient is when you're talking about real world data. It's not going to line up and make a nice, pretty line. The closer it is to a pretty line, though, the closer your correlation coefficient is going to be a positive one or a negative one. Positive one if it's a positive slope, negative one if it's a negative slope. Okay? But that's what this is. It's really strong. It's pretty darn straight. A 0 is, it looks like you took a bag of marbles and you threw it on the floor. It doesn't make sense. It doesn't even look like a straight line. Your calculator, this page, shows you how to make your calculator calculate this for you. You do not want to do this by hand. Okay? All right, number 2, what is the name of the line of best fit representing a set of bivariate data? This is a regression equation. So that same little half page tells you how to do linear regression, how to write an equation using linear regression, making the calculator do it for you. All right, so what we're going to do first, we're going to create a linear model using average rates of change. So average rates of change, remember, is the lowest and the highest, and we do the y's. So we're going to do 8 minus 3 over 10,000 minus 0. That's how we're going to get the slope of this line. Put a decimal at the end, the bottom of the fraction. That is your slope. Okay, I'm going to write it bigger. So f of x equals 0.3 zeros. 1, 2, 3, and then a 5. And then you tack the x onto the end. Your y-intercept, where x is 0, this number right here, that's your y-intercept. Okay? All right, number 4 says use linear regression. So I'm going to zoom back out on this. Hopefully I can fit everything on the screen at one time. I may not be able to, though. Let's try this. All right. Linear regression. Ugh. All right. In my calculator, I'm going to clear everything out. I'm going to do the data, list and spreadsheets. It's the same calculator you have, but it's the software for it. Row A, I type an X. Row B, I type a Y. I type the X's. It's the little green table looking one. All right, and then I type the Y's. Don't. You're gonna throw me.
How do you look at it and type? That takes me forever. I'm like,
Because I learned how to type properly. I don't have to look at my hands. All right, so X's go under X, Y's go under Y's. This blue box needs to be under your last data set. Okay? So again, that sheet, it tells you the buttons. Right here, menu, 413. Menu, 413. X list needs to be X, Y list needs to be Y. That's why we type them into the A and B. And then you can just hit OK. All right, the M value, that's what this starts with. So f of x equals 0.00068x. And then the b value, that's what's added to the end, plus 3.2 0.27326. So what that is,
Teachers, I just wanted to let you know that you're great.
so same set of data, I wrote two different equations, okay? This next box, the correlation coefficient, on this same screen, that linear regression screen, this R value, no, right here, not the R squared, the R value. That is your correlation coefficient. We typically round that to two numbers after the decimal.
So you get this from where?
This is that linear regression. This is that doing it on the calculator, doing linear regression.
Oh, just the R?
Yeah, the R, not the R squared, the R value. So that means if I graph this data, 0.85 means that this data would be fairly straight, and it's going to have a positive slope. That's what I can tell from that correlation, is how tightly the data is correlated, how related it is, how accurate it is.
I know you told us this.
No.
I have all my stuff in there. What do I post in?
Menu
Menu.
413. All right, so how we determine if is the linear model using average rates of change reasonable? What we look at is we look at the correlation coefficient. If it's a strong, means it's pretty close. I would say, again, looking at this page, if it's greater than 0.5 this way, and then less than negative 0.5, so negative 0.7, negative 0.8. In those range, you're talking pretty strong. But the other thing that you have to look at is how these two match up. Okay? So if we look at this, we got 0, 0, 0, 5. Here we've got 0, 0, 0, it would round to a 7. When we're talking in the grand scheme of things, those numbers are really close, okay? And then you look at the constant, 3 compared to 3.27. Those are really close. Not really close would be if the slope here was 5 and the slope here was negative 10. If this constant term was a 26 and this one was a negative 32. Those are not close. If they're close, if they're reasonable, if somebody owed you $3.27, would you take $3 from them and call it even?
Yes.
Yeah, $3 is better than nothing. So this one is, yes, it's reasonable. But if these two numbers are way off, or if these two numbers are way off, way different, it's not reasonable. Okay? So you are going to do the same thing here. You're going to do average rates of change, which is the smallest and the largest, and write an equation here. Then you're going to do linear regression for this one. Put your R value here, and then comparing your two equations, tell me, is it reasonable? Yes or no? I will. There? Is that good?
Yes.
Okay.